Okay, so we're going to work on interpreting a time-distance graph. And we have one here, and we're going to make up a story to go along with it. We'll talk about what each of these lines means, and we're going to try to build a story to go with this. So we're going to say that the general idea of this is taking the bus to school. Okay, so let's assume that it's a student, and he's got to go to school, and he starts at home. Okay, the concept. So he has a bus that's across the street from his house, and he starts taking the bus. Okay, and it's a pretty fast bus. And at 20 minutes, he realizes something. Okay, he essentially stops. So he's probably not on the bus anymore because I highly doubt the bus would just stop with him in it for a time of what looks like 10 minutes. So for 10 minutes, he's sitting around. Then he hurriedly heads back to where he started. Okay, so maybe, and again, we're making this all up, but the concept of this is he travels away from home. So let's say student gets on the bus, then jumps off the bus because he's frantically looking for his homework, which he realized was due today, or his assignment. He's waiting.
Waits
he spends
10 minutes for the bus, then goes back.
Yeah, heads back home. He spends 10 minutes there. What's he probably do in those 10 minutes?
That bus seems faster.
Yeah, I know, eh? Probably this was an express.
Yeah.
This was an express bus to get home. Then from here, spends maybe 10 minutes looking for his homework, jumps on the bus, it looks like it's probably another express because it's going pretty quick, gets to school, and then he's in class for 10, 20, 30 minutes. So let's just assume he only had to be there for one period and he was late. Maybe he was supposed to get to school here and spend, or maybe here and go 10, 20, 30, 40, 50, 60, an hour in class. But because he had to go home, okay, he didn't quite make it. So he gets there, he spends 30 minutes in class, and then he gets maybe he gets a drive home, and that's why he gets home so quickly. But the idea of this is we can find out a lot of mathematical information from this. So let's assume that's a story. He got there, forgot homework, went home, got homework, booked it to school, went to school, came back home. Let's assume that's the taking the bus story. There's a lot of actually rates in this, okay? For instance, in the first one, he traveled how far?
300 kilometers.
Well, actually, these are tens. It does look like hundreds, but this is 30, looks like. So this point would be 20 minutes and 30 kilometers, which means you could really find out a speed at this time, right? If that's minutes, okay, and we're trying to find per hour, we know we can multiply that by 3 to find out his speed, right? Because there's 60 minutes in an hour. So if you multiply by 3, he was going 90 kilometers an hour. That is an amazing bus. Okay.
Most buses only go like 60.
Yeah, that must be, maybe he was a train this guy took to school. Okay. And then for 10 minutes, he doesn't go anywhere. He stays in the exact same spot. So maybe he's frantically looking through his bag for another 10 minutes. Then he heads back home. He goes another 30 kilometers, but in a negative direction, and he does it in 10 minutes. Okay? We know that to find a rate, if we want to find kilometers an hour, well, how many minutes are in an hour?
60.
60. So we'd have to multiply this by 6, which means he travels at 180 kilometers an hour. Amazing. We need to get one of these buses.
Double the speed.
Yeah. He gets home, finds his assignment.
Maybe it's an RT.
I don't think even the RT. This must be a bullet train this guy's taking to school. Okay, so then at the 50th minute from when he left, so he's probably for sure late, he leaves again. He then travels 50 kilometers over the course of 10, 20 minutes again. Okay, 20 minutes, 50 kilometers. If we multiply by 3, that'll take us to 60 minutes. He goes 150 kilometers an hour. A great bullet train to get to school. Then he's at school for 10, 20, 30 minutes. He's in class, so he clearly missed half a class. Otherwise, that's a great school. You only got to go for 30 minutes. And then he does the ultimate. He travels 50 kilometers back home over the course of 10 minutes. Okay? We got to multiply by 6, right? To make this 60 minutes. Which would make this, if we multiply by 6, 300 kilometers. So he travels at 300 kilometers an hour to get home. He really wanted to be home. Maybe it's just Superman. Maybe this was Superman going to school, and this makes sense. But that's essentially the type of information you can take from a time-distance graph. It helps tell a story, and we can figure out distances. So distances are our changes in our y, and our times are the changes in our x values. Okay? Our independent is time, and time is always our independent, and our dependent is our distance in this case. Okay? Okay.